Hello everyone. In the last video we discussed about that how we can calculate the valency factor for the redox reaction. Now we will apply the equivalent concept for solving the problem based on the redox reactions or redox titrations. Before this, we should remember some important point regarding to this. So to solve the stoichiometric problem by using the equivalent concept related to the redox reaction or redox titrations, first we should write the expected redox changes in the given reactions, and we should find the oxidation number of the oxidizing agent or reducing agent. It is to be noted that reducing agents are those which shows increase in oxidation number, which shows increase in oxidation number, while oxidizing agent or oxidants are those which shows decrease in oxidation number. After identifying oxidizing and reducing agent, we will find the N factor of all of them. N factors of each species which is undergoing oxidation and reduction, it is to be noted. And now we will use only one concept, which is equivalent concept. So have a look on the equivalent concept in brief. According to this, first of all, there is no need of balancing reaction. No need of balancing reaction. And according to the equivalence concept, mass of substance, mass of reactant or product reacting in a reaction, taking part in the reaction, is directly proportional to its equivalent mass. So the number of equivalents of each reactants and products are constant. So for a reaction A plus B, this will give C plus D. We can relate the equivalence of A, equivalence of B, equivalence of C and equivalence of D like this. That equivalence of A is equals to equivalence of B is equals to equivalence of C and equivalence of D. It is to be noted that equivalence is number, which is W by E, and where E stands for the equivalent mass. So this number of equivalents can be written in the three form basically. The first one is W by E, that is equal to W, and we know that equivalence mass is molecular mass or atomic mass upon N factor. So we can write this, it will be M by NF, and W by M will be moles. So the second formula of the equivalence will be N into N factor. Also, this can be put equal to the normality into volume in liter. So according to the question, in which format question has been asked, we can use the equivalents, like W by E is equals to N into N factor, that will be equal to N into volume in liter, where not N stands for the normality, and normality will be equal to the molarity into N factor. So after finding the N factor of each oxidizing and reducing agent, simple we can use that जिसका डेटा दिया है उसके इक्वलेंट इक्वल रख दो. What I said, जिसका डेटा दिया है उसके इक्वलेंट इक्वल रख दो. The general mistake to solve the problem based on the equivalent concept is that we misconcept in equivalent and milli-equivalents. So it is N into V, it is in ml, and if we are saying that it is equivalent, it is wrong. It is milli-equivalent because volume is taken in ml. So N into V into liter, this is equivalent, and this will be equal to N into V ml divided by 1000. So these are the some of the important points that is to be remembered. And one thing more, in case of permanganometer titration, we should take care about the medium in which the reaction is basically occurring or taking place. For example, We know that CaMnO4 gives different products into different mediums, so it has different N factor, valency factor, so different equivalence. For example, CaMnO4 in acidic medium converts into Mn plus 2. So the change in oxidation number will be plus 7 to plus 2, that will be plus 5. Definitely the N factor of this will be 5. And N factor of this will be 5. And MnO4 minus in alkaline medium will convert into MnO4 minus 2. The oxidation number of manganese in this will be plus 6, and this here is plus 7. This is permanganate ion, this is magnet ion. Permanganate ion is purple in color while the magnet ion is green in color. So the oxidation number change will be 1, so the N factor will be 1. Now MnO4 minus in weakly alkaline medium or neutral medium converts into MnO2. So the change in oxidation number will be from plus 7 to plus 4. So N factor of MnO4 minus will be equal to 3. We can take some more compounds in which how we can calculate the N factors, like K2Cr2O7. K2Cr2O7, which is dichromate. Chromium is in plus 6 oxidation state. Dichromate changes into Cr plus 3 in acidic medium. So there will be change in the oxidation number from plus 6 to plus 3. So N factor of dichromate will be 6, and here N factor will be 3. Next one is H2O2. H2O2 converts into H2O plus O2. So we can say that oxidation number of oxygen is changing from -1 to -2 and 0. When H2O2 converts into H2O, it is showing decrease in oxidation number, so it is acting as an oxidizing agent. So when H2O2 acts as an oxidizing agent, water will form, and when H2O2 converts into O2, it is decreasing its oxidation number, increasing its oxidation number, so it will act as a reducing agent. So it should be noted that H2O2 can act as a disproportionating agent because it can increase or decrease in its oxidation number. But when it will act as an oxidizing agent, water will be formed. When it will act as a reducing agent, oxygen will be formed. But in both cases, when it acts as oxidizing agent or reducing agent, N factor will be 2. While when it acts as a disproportionating agent, the N factor will be 1. We have calculated the N factor of H2O2 in the last video. Now third is H2C2O4, which is oxalic acid. So with respect to oxalic acid, we can write that oxalate ion C2O4 minus 2 converts into CO2. So change in oxidation number will be from plus 3 to plus 4. So N factor of this will be 2 and N factor of CO2 will be 1. This is oxalic acid. Students should be careful about the ferrous oxalate, because the ferrous oxalate converts into Fe plus 3 and CO2. So two different elements in the same compound is getting oxidized. So the N factor in this case will be 3. And number 4 is ozone. Ozone is diamagnetic and oxidizing. So when ozone is taken, it can convert into O2 and O. Definitely the oxidation number will be 0, 0, and here is -2. Fifth is Na2S2O3. This is sodium thiosulfate or hypo solution, which will be used in iodometry and iodimetry titration. This is hypo solution. So hypo solution S2O3 -2 converts into S4O6 -2, which is tetrathionate. So the oxidation number is 2 and 2.5 respectively. So the N factor of these will be 1 and 2 respectively. Now let's understand how we can use equivalent concept to solve the problems by using the redox reaction or redox titration. Now let's start with the first question. Calculate the number of moles of camenophore which will react with 180 gram of H2C2O4 according to the reaction. Also calculate the volume of CO2 produced. So as I told you that first you will write the expected redox changes. So in this reaction, MnO4 minus plus C2O4 minus 2 is taken, and the redox changes expected I am writing here. So C plus 3, C2 plus 3, and now C plus 4, and this is Mn plus 7 to Mn plus 2. So the N factor of MnO4 minus in acidic medium will be 5, and N factor of oxalate will be 2. So simply we can relate the equivalent of camenophore with equivalent of H2C2O4. As I told you that जिसका डेटा दिया है उसको इक्वल रख दो. तो 180 ग्राम of H2SO4 means moles of H2C2O4. Moles of H2C2O4 oxalic acid will be 180 divided by 90. It will be 2. So equivalent of camenophore will be equal to equivalent of H2C2O4. Simply number of moles of camenophore is required to calculate. So N is the moles, N factor is 5, N into N factor, that will be equal to 2 moles of H2C2O4, and the N factor is 2. So the number of moles will be 4 by 5. It is the required answer. In the same way, in the second question, it has been asked to calculate the volume of CO2 produced at STP. So definitely, when we will see it, the equivalence of CO2 will be same as H2C2O4 or camenophore. So the equivalence will be 2 into 2, that will be equal to 4. And we know that N factor of CO2 we can calculate as change in oxidation number and into number of atoms which is undergoing oxidation or reduction, that will be 1. So the equivalence of CO2 will be 4, and this will be the moles of CO2 also because N factor is 1, right? So the moles of CO2 will be 4. So we can convert this into volume at NTP 4 into 22.4 liter. This will be the required answer. In the second question, it is given that calculate the mass of K2Cr2O7 required to produce 254 gram of I2 from Ki solution. So we will write the expected redox changes. ये I minus, and this will produce I2 and Cr plus 3 plus 6 plus 3. N factor will be 6, and here N factor will be 2. We can say that equivalent of dichromate and equivalent of I2 is required to relate. So simply equivalence of K2Cr2O7 will be equal to equivalence of I2, right? So mass is required to calculate, which is W, and the dichromate molecular mass is 294, and the n factor will be 6. ये moles हो गए, and this is n factor. And now for I2, 254 divided by 254, it is moles, and the n factor is 2. We can solve this, and on solving we will get 98 gram of dichromate is required. In the next question, volume of camenophore 0.05 m, which will react with 50 ml of 0.1 m H2S, is required to calculate. So expected redox changes, H2S plus, we can say that ionic reaction we can write, S minus 2 we can write, and MnO4 minus, this will give Mn plus 2 plus SO2. The changes in oxidation state of sulfur we can find from this, S minus 2 to S plus 4. So minus 2 to plus 4 and plus 7 to plus 2. So the n factor of this will be 5, and n factor in this case will be minus 2 to plus 4, n factor will be 6. So simply we can relate the equivalence of camenophore, that will be equal to equivalence of SO2. In this case, it should be noted that we want to calculate the volume, and here is the volume is given in ml. So definitely we are putting the milli equivalent, we are dealing with the milli equivalent. So the milli equivalent of camenophore will be equal to milli equivalent of SO2. So 0.05 is the molarity, and n factor is 5. This is normality, and now VML. Now this has become milli equivalents. Now 0.1 into 6, it has become normality, and into 50, now it becomes milli equivalents. So we can calculate this, and the volume you will get will be 120 ml, right? Let's take another example in which Fe3O4 completely reacts with 25 ml of 0.3 m K2Cr2O7. Again we will write the expected redox changes. It will be Cr2O7 minus 2 plus Fe3O4. Obviously oxidation number of chromium will change from plus 6 to plus 3, and Fe3O4 will be converted into Fe plus 3, because the oxidation number of iron in this will be 8 by 3. So it is increasing its oxidation number, so it will be reducing agent and it will be oxidizing agent. So simply we want to relate the dichromate K2Cr2O7 with the Fe3O4. जिसका डेटा दिया है उसको इक्वल रख दो, तो equivalence of K2Cr2O7, that will be equal to equivalence of Fe3O4. Now 25 ml is given, so we must be careful about this. So 0.3 is the molarity, n factor is 6. Now it becomes normality, into 25, it is milli equivalent, it is divided by 1000, it becomes equivalence. That will be equal to W is the mass of Fe3O4, 232 is the molecular mass of Fe3O4, and n factor in this case will be 6, and Fe3O4, the n factor will be 1. So n factor will be 1, because change in oxidation number we can find, and we can multiply this by 3, which is the number of atoms undergoing changes. So W we can calculate, this will be 10.44. Now we can take one more example that calculate the concentration of H2O2 solution. If 20 ml of H2O2 solution reacts with completely with 10 ml of 2m camenophore in acidic medium. To be noted that acidic medium is given. So first we will write the expected redox changes, MnO4 minus plus H2O2. This will form Mn plus 2 plus O2. To be noted that plus 7 to plus 2, it is decreasing its oxidation number, so it is oxidizing agent. Also the N factor will be 5. Obviously, in presence of this oxidizing agent, H2O2 will convert into O2. The oxidation number is increasing, so it will act as a reducing agent, and N factor, as I told you, that H2O2 will be 2. So simply we can relate the equivalence of KMnO4 and equivalence of H2O2. To be noted that we are relating the milli equivalence because the volume is given in ml, right? So what we can say, 2 is the molarity, N factor is 5, and this become normality, and we will multiply this by volume, which is 10 ml, so this is the milli equivalence, right? Now this will be equal to 2 into 5 is the N factor, and 10 ml we have taken. Now concentration of H2O2 is required to find, which is X, and the N factor will be 2, and the volume is given as 20, right? So we can solve this, and what you will get, X equal to 2.5 m. This will be the concentration of H2O2. In the same way, calculate the moles of KCl required to produce 10 moles of Cl2 by the reaction with KClO3. Calculate the moles of KCl required to produce 10 moles of Cl2 by the reaction of KClO3. Expected redox change, first we will write ClO3 minus plus Cl minus. This will give Cl2. So the change in oxidation number will be from plus 5 to 0. So the N factor of this will be plus 5 to 0. So change will be 5, and for the Cl minus, the N factor will be 1, and for Cl2, N factor will be equal to 2. N factor will be, when it acts as an oxidant, will be 2 into 10 and 2 plus 10. So this will give 5 by 3. So now we can relate the moles of KCl is required to calculate. So equivalent of KCl will be equal to equivalence of Cl2. So we can say that the moles of KCl is X, N factor is 1. So N into NF of Cl2 will be this. On solving this, for X you will get as 16.66. Let's take one more example in which it is required to calculate moles of KMnO4 for oxidation of 1.25 moles of Cu2S. So we are writing the expected redox changes. MnO4 minus plus Cu2S. MnO4 minus will be converted into Mn plus 2, and this will be Cu plus 2. Mn plus 7 to Mn plus 2, N factor will be 5. Cuprous sulfide, so N factor of this will be 8. So we can say that equivalence of KMnO4 will be equal to equivalence of Cu2S. So this will be N into moles of KMnO4 will be N, so N factor will be 5, and moles of Cu2S is given as 1.25 moles, and N factor is 8. So we can calculate N will be equal to 2 moles. And the last question, it is required to calculate the volume strength of H2O2. We know that volume strength of H2O2 and molarity is related as M equal to Vs upon 11.2. Now how we can relate this? We can relate this data as K2Cr2O7 is given, So we will write the expected redox changes Cr2O7 minus 2 plus H2O2. This will convert into Cr plus 3 and O2. So the N factor of H2O2 will be 2 and N factor of dichromate will be equal to 6. In the same way we can proceed that. First we will write the equivalence of H2O2, that will be equal to equivalence of K2Cr2O7. Again we are dealing in the milliequivalence because the volume is given in ml. So 0.5 into N factor will be 6 and into 30, this will be the milliequivalence of K2Cr2O7. In the same way, at the place of molarity we can write that Vs upon 11.2. This is molarity into N factor is 2. Now it becomes normality and now Vml. So this will be the equivalence of H2O2. So on solving this, what we will get, volume is 11.2 is given, 11.2 is given, 11.2. So now on solving this, we will find that volume strength of H2O2 will be 45. So these are the problems which is based on the redox reaction or redox titration by equivalent concept. Please like, subscribe and share to get more such informative videos for all of you. Thank you very much.